This is problem number 10, and it's got 4 parts, and this is the problem several people have been waiting for. If you have your book handy, it's page 427. In the online book, just go to the end of chapter 4 and find the chapter test. So all the ones that are practice tests should have a PT. So those are the ones, if you go through the list, make sure you do all the PTs. I might have a mistake or two in there, but that won't hurt. All right, part A. Let me read it from the book. Find a function. They want you to find a function, and it's PERT because I can see an E in the book. They use different letters. I try to be consistent and always use PERT. A is how many you end up with, P is what you start with, rate and time, and E is always E. It's 2.7 something. All right. The initial size of the number of bacteria, there were 1,000 bacteria. An hour later, there were 8,000 bacteria. So find a function that models it. So we're starting with 1,000, and we're ending with 8,000. And we need to know the rate, but we know the time was 1 hour. You can just sort of ignore that 1 up there. Remember, anytime you have both A and P, if you know them both, you should always divide that first. So when you divide those two, you will get 8. 1,000 goes into 8,000 8 times. And T was 1, so we don't need to write the 1. So 8 equals E to the R. What do we do next? Well, change to a log. What's our base? E. You don't have to write the E. Base E of, go over the equal sign 8. Equals, come back R. Oh, R is just this. And we can do that on the calculator. Hit the LN button, 8. And you'll get 2.079. That's the rate they're granted. So now we can write the formula. It's PERT, but we know some details. We know that it's starting with 1,000, and we know the rate is 0.2.079 T. Now they use slightly different letters in the book, but that's okay. You can use those letters, or you can switch to the ones I'm using. All right, now part B. Find the population after 1.5 hours. And the time, what did I just say? I forgot. 1.5 hours. Just do this on your calculator. And that's how many bacteria will be after an hour and a half. And I got 22,000. Nope, that can't be right. I'm glad I brought my calculator. Well, I thought I brought my calculator. Oh, here it is. This seems like an awfully big number. All right, so that's 1,000. Shift E, 2.079 times 1.5. 1 hour is 10,000. Hour and a half is 22,612 bacteria. That's the answer to part B. So A was to come up with a formula. That's A, and this is B. Put in 1.5 and get your answer. Now let's go to part C. Reading out of the book. How long will it take to go all the way up to 15,000? So let's go back to our formula right here. And we know we're going to end with 15,000. And we start with 1,000. E to the 2.079. But we want to know how long is it going to take. We don't know time. How long will it go from 1,000 to 15,000? What do we do first? We divide that into that and we'll get 15. Now, anytime you're solving for an exponent, you have to go to log. And if you don't show that step, you don't get credit for the problem. So go to a log. It's going to be base E because that has the exponent. When it's base E, of course, you always put ln. You don't have to write the E. Of, well, we did E, so we got to go over the equal sign, 15. Come back, and we're left with 2.079t. Do this, divide by 2.079, and it will take 1.3 hours. Let's see, this was number 10. Says, sketch a graph of the function. And this was our function right here. It's a exponential function. Well, it's exponential, it's not log, there's no log in here. So the exponentials always go like this, unless they have a negative exponent, that would be decay. And what point does it normally go through? 1, except this one is 1,000 times taller. So that point right there is 1,000. That's our starting. This is 0, and we're starting at 1,000, and it grows. So if I went over 1.3 hours, I'd be up at 15,000 already. Okay.